Hey guys, welcome to your video notes 4.4 absolute maximum and minimums. So previously we looked for relative max and minimums in open intervals where we couldn't confirm whether that was the ultimate max or the ultimate min. However, if we have a finite closed interval of a continuous function, then it must, let's make sure we underline that, continuous function must have an absolute max or min, because there is going to be the highest value and the lowest value on a closed interval. So here are a few examples. Now this is an open interval. I added arrows on to where they should be. So it's an open interval. It keeps going on forever. So it does have an absolute minimum here because it keeps on going up. However, there is no absolute max. This function, it keeps on going forever, has no absolute extrema. Now this one, I think they wanted to have a horizontal asymptote implied there, so I drew mine. So we could see there is an absolute maximum here, and there are absolute minimums here because the rest of your function is going to balance out. This one has no absolute extrema, and this one has an absolute max here on this included endpoint, and this one has an absolute min on that endpoint. So, Theorem 4.4.2, the extreme value theorem. So this is one important one. The way I remember if theorems are important or if they really give them a name, right? So if there's a name for a theorem, that means it's one that's going to be brought up quite a bit. So the extreme value theorem, if f is continuous on a closed interval, then it must have both an absolute max and an absolute min in that interval. Extreme value theorem is going to come up quite a bit. And it has, if it's on an open interval, then it must occur at a critical point, okay? So here are a few pictures where we have continuous function on a closed interval. So if I have a continuous function on a closed interval, I know I can use the extreme value theorem there, right? Because that applies to continuous functions on a closed interval. So I know that the extreme value theorem confirms that there will be both an absolute max and an absolute min on these closed intervals. Well, where are they? Well, in this closed interval, here is my absolute max, and here is my absolute min over the closed interval. In this closed interval, this point here looks to be my absolute max, and this point here seems to be my absolute min. And then for this interval, closed continuous interval, the extreme value theorem confirms that there should be an absolute max here, and this point looks to be the absolute min. So the extreme value theorem is for closed intervals looking for absolute max and absolute min. But if you have an open interval, then you can have an absolute extrema, but it must occur at a critical point, okay? So let's try some problems together.